to Elevate Chem. It's Jesse here with another concept video, and this time it's our part 3 in our 5-part series on redox. And once again, we're going to be looking at a question because ultimately the best way to learn a concept is by learning how it's applied in an actual exam. As always, the first thing I want you to do is have a crack at this question. This is the HSC 2014 chemistry exam, and I want you to have a go at question 28. So pause the video now, have a go, and I'll see you on the other side. Fantastic. Now this was a great example of a question where it was really important to understand the real sort of basic fundamentals that was going on behind the scenes here. So I'm going to get cracking right into it. I'm going to ignore this diagram for now and instead read the question. Explain the color change in the copper half cell as the reaction proceeds. Fantastic. So I already know a couple of things. There's a color change going on, and there's copper, and there's a half cell. It sounds like a galvanic cell. And sure enough, if I look at this diagram above, it certainly looks like a galvanic cell. Now the first thing I want to focus on is I know I'm dealing with the copper half cell. So I'm going to make sure I'm focusing on that. And what I need to be looking for is the color change in the copper half cell. So I notice that it says here it's a blue solution, and somehow this blue color is going to change as the reaction proceeds. Well, let's try and work out how. Well, we know that it's a blue solution, and the only thing that could be causing it to be blue is whatever is making up that solution. And the solution is this copper nitrate solution. And you might know, you might not know, doesn't matter too much, but the copper is the actual element that's making it blue, specifically the copper 2+. So basically we need to work out what happens to this copper 2+ as the reaction proceeds. Now, it's mentioned here that the copper metal is the cathode. It's also given the plus, just in case you're not sure. Of course, with a galvanic cell, the cathode is the positive cell. Now, what happens at the cathode is a reduction. So that means some sort of reduction reaction is taking place, and reduction is a gain of electrons. So that means I'm going to have something plus some electrons producing something else. And I know that it has to be something to do with copper. So I'm going to take a guess, and hopefully you might know this anyway, but that when I add these two things together, the thing that I'm going to produce is copper solid. And the reason why I know that it's actually going to be on the right hand side is I need to balance my charges. So that means whatever's positive needs to be on the left hand side to counteract this negative charge. So I'm going to include that my Cu, of course, would be aqueous. 2+ is on my right hand side, and that would mean I need a 2 there just to balance that equation. So this is the reaction that is occurring in this copper half cell as the reaction proceeds. So what happens is my copper 2+ is slowly actually getting converted into solid copper. And if it's the copper 2+ that's actually causing my blue solution, as the reaction proceeds, there's going to be less and less of this copper 2+ in that solution, and that means that there's actually going to be less and less blue color. So ultimately what it came down to with understanding this question and knowing what to do was actually understanding the fundamentals of a galvanic cell and how it progresses. Reduction takes place at the cathode. That means that these ions are going to be used up. So right now, I'm going to write that down. So explain the color change as reaction proceeds. Cu2+, and I'm going to add in my state. Aqueous is reduced to Cu solid, causing less Cu2+ in solution. And I'm going to write sol with a dot as my little shorthand, causing less blue color. Things you might have been stumped with is assuming that the nitrate might have potentially been causing that blue color. But then, of course, the nitrate isn't actually participating in this reaction, and therefore it wouldn't really be changing. And it'd be a bit of a weird question if they're asking for explain the color change without any color change occurring. So let's jump into part B. The theoretical standard potential for this galvanic cell is 2.02 volts. Identify metal X. Now metal X, it's sort of given to us as being the anode over here. So what you're going to need to understand is the concept of the electrochemical series, and you're going to certainly need to know this little equation here. So theoretical standard potential, and I'm going to read that as E naught is equal to E of the anode plus E of the cathode. Now we actually know one of these values, and the one that we do know is copper. And the reason why we know copper isn't because of anything on this page, but because of the fact that we can actually look up these values in our data sheet. So you'd flick to your data sheet and you would find that E cathode is equal to 0.34 volts, and it's given that the total is 2.02. So that means 2.02 equals E anode plus 0.34. Therefore, E anode equals 1.68 volts. Now, how am I going to use that to get a metal? Well, once again, it's using that data page, finding the electrochemical series, and you're going to find that, therefore, metal X is aluminium. So this entire question boiled down to, can you look at the data page and can you find things on the electrochemical series? If you could, this question wasn't too challenging, but if you sat here looking at this question going, where am I going to get this data from? It's on the data page. That's pretty much always the case, guys. If you can't find something directly in front of you, look at that data page. So there's a couple things to focus on in this question here, guys. The first thing was to have a real basic, good, solid understanding of how a galvanic cell functions, whether it's an oxidation, whether it's a reduction, and what occurs under those situations. The second bit was to understand the electrochemical series, how you use it with this little equation here, and then of course how you find that information by going to your data sheet. Fantastic. I look forward to seeing you in the next episode.